Paper 1, question 11 for the mock. Hopefully that picture is quite visible. This is a tricky one to kind of try to represent. Again, I don't have the skills to be able to kind of put this into the video or whatever. So, like I said, if you're looking at the graph, hopefully this should be enough. You're not going to be able to count squares with me, but just trust me that it should match exactly what you have as far as the question in front of you is concerned. It's talking about Debbie driving between junction 12 and junction 13 on a motorway. So this graph is representing how far away from junction 12 she is headed and how long it's taking for her to do that. So this is a distance time graph. The fact that this line is straight means that she is driving at constant speed, okay? So you can assume that her speed throughout is constant. It tells you that Ian also drove from junction 12 to 13, and it gives you his actual speed as 66 kilometers per hour. Okay, who had the faster average speed, Debbie or Ian? And you must explain your answer. This is one of those star questions where you have to give the details of why you're doing what you're doing. Okay, so the key to this really is find out Debbie's speed, make a comparison, and then come to a conclusion. What some people have done, that I saw when I marked this, so what some people have done is they've actually used Ian's speed and plotted a graph for that, and then compared whichever one was steeper, has the faster speed, and come to their conclusion. That's totally fine in terms of this question, and it works out quite nicely. As far as what I think the expected way of doing it is, and what I will show is, I'm going to use the information in this graph to determine Debbie's speed and just compare the numbers rather than compare the graph. But as long as you've justified what you've done right the way through the question, if you are right or within a certain leeway of being correct, then you get the full marks for it. Okay. The first thing to do is, if you're going to use this graph to determine Debbie's speed, what you need to make sure you do is that you identify a point on the graph, or a point on this line, that is clearly defined as crossing the corner of a square. Now what I mean by that is that you pick a point on that line where you can clearly see that it is so much time, and you can clearly see that it's so much distance. You don't want to start rounding, or if it kind of goes halfway through, just assuming it's half. There will always be at least one, usually there's 3 or 4 clearly marked points that you can identify. My best bet as well is that you pick one that is furthest up as well, because if you were to try and identify one that's up close, what you think that line is done between there and there, so let's say you might have thought it goes along 3 squares and not 4, and then you've marked that point. The further out you get, that could slightly stray from it. One of the reasons why in this question you've got sort of a range of answers that are correct. It just so happens that the end point of this line is perfectly in line with 30, and is also perfectly in line if we go down with 24 squares up, 24, okay? So that allows you to quote the distance as being 30 kilometers, and the time as being 24 minutes. Okay? From that, you can find the speed. If you know the distance, you know the time, you can find the speed. Speed being distance over time, which in this case is 30 kilometers over 24 minutes. You do 30 divided by 24, or you simplify that fraction until you get a nice answer. If you do 30 over 24 and break it down, you end up with 15 over 12, then 5 over 4. You end up with 1.25 kilometers per minute, because you're using the number 24, it's involved in minutes. We have 1.25 kilometers per minute. So in order to make this comparison, we have to change that speed to kilometers per hour. 60 minutes in an hour, multiply this number by 60. So her speed will be 1.25 times 60 kilometers per hour. You multiply 12.5 by 10 first of all. So 1.25 by 10, you get 12.5. and then you multiply that 6, so I broke down that times 16, times 10, times 6. And from that, you get to 75 kilometers per hour. Okay, so Debbie's got 75 kilometers per hour, Ian's got 66 kilometers per hour. We know Debbie's faster. We have to clarify that though to get the full marks, okay? How would you do that? Well, 75 is bigger than 66. You would say that, so we put that in terms of using maths notation, mathematical notation. 75 is bigger than 66. So usually when you make this comparison to answer a question like who's faster or slower, or who's older and younger, or did they make it in time, or whatever the question's about, when you get your answer and you compare it with a number, one is going to be bigger than the other, so you kind of make this statement. Therefore, kind of like a little 3 dots in a triangle, therefore, and then you answer the question. So, who had the fastest speed, Debbie or Ian? 75 is bigger than 66, therefore, Debbie drove faster. Or Debbie had a higher speed, or whatever. As long as you declare the fact that Debbie was quicker than Ian, or Ian was slower than Debbie, you'll get your full marks from that.